Okay, so welcome back. We are on day 3 of LEP 5. So here we're going to talk about equivalent ratios. Looking at the brain teaser, go ahead and pause this video, try some things and see if you can get it. Okay, so here we're talking about distances, rates, and times. So what comes to mind is our distance formula. Distance is equal to rate times time. So here, Mai finished a 100-mile bicycle race. So here, this is the distance is 100 miles, right? If Mai traveled 5 miles per hour, that's a rate faster, she would have finished the race in 4 hours. So here, if we have our rate equal to rate plus 5, or our R2 is equal to our original rate plus 5, then our time would be 4. So R1 is our original distance that we want to solve for. R2 is if she traveled 5 miles per hour faster. And so those are different quantities, R1 and R2. So if Mai traveled 10 miles per hour slower, so here our R2 is equal to R1 minus 10, so 10 miles per hour slower, then the time would be 10 hours. Okay, so we have a lot of information going on here. So using my formula that I have here, I'm going to go ahead and solve for R because that's what we want to solve for. So solving for R, what does that become? D over R. I'm sorry, not R. D over T is equal to R. So that's what we want to use. D over T is equal to R. So using it with the two scenarios, here we have, I'm going to put scenario 1 and scenario 2. So scenario 1, distance over time is 100 over the time when T is equal to 4. Our R is what? Here, this 100 over 4 is equal to 25. So I'm going to just go ahead and put 25. 100 divided by 4 is 25. And that is if she traveled, if this is equal to R2 right here. If she traveled 5 miles per hour faster. So this is equal to R2, which is ultimately equal to R1 plus 5. So I can subtract this R2 right here and just put this is equal to R1 plus 5. Doing the same thing for 2. So here our distance is still 100. Now, instead of 4 hours, this is 10 hours. So we have 10 hours. 100 divided by 10 is 10. And what is this equal to? Well, this is equal to R1 minus 10 if she went 10 miles per hour slower. Okay, so now we have these two equations. And is there an R1 that satisfies both? So looking at equation 1, R1 plus 5 is equal to 25. Well, solving for that, R1 must be 20. Does it work here? 20 minus 10? Yes, that's 10. So here, from these hints, she travels 20 miles per hour. So it took her 20 miles, or I'm sorry. Now we have to answer how long did it take Mai to finish the race? So now we have to solve for T, knowing that, so D is equal to R times T. Solving for T, we have D over R is equal to T. Plugging in our D over R, so distance is 100, and then we found R to be 20. So 100 divided by 20 is 5. So it took 5 hours to finish the race because the race was 100 miles and she traveled at a rate we said 20 miles per hour. I'm going to put miles per hour that way. Okay, so a lot with our distance formula. So let's move on to some vocabulary. I'm going to go ahead and erase these guys because it's in our way. Okay, so slope formula. So the slope formula is m is equal to y2 minus y1 over x2 minus x1. So this is our slope, and it's denoted m. So kind of get used to that. That slope is denoted as just m, and there's our formula where y1 and y2. So there's some facts here. So we have 2 points. We have our first point is x1, y1, and our second point is x2, y2. So we get those points from a graph, or they're given to us, and as long as we have 2 points, we can solve for that slope, what the slope is between those 2 points. So, you know what, I'll draw it over here. I'll draw something at each of these. So examples, so here we have column 2 points, there's a line. Here, if you can see, if this was x2, y2, x1, y1. So here is, if you want to think about it, this is our y2 minus y1 is our vertical change, and x2 minus x1 is our horizontal change. So you can think of it as, let me color code it. So here y2 minus y1 is this change. And then if I wanted it in purple, the x1, that's a little bit too big, is this change. So you also see it as rise over run. I learned that way. The rise, how much we rise and how much we run. Whether it be positive or negative, either way. So some non-examples, you guys can come up with that on your own. So let's go ahead and go to the next one. You know what? A good non-example, a common mistake that students make is they'll switch these. They'll say this is x1 minus x2 over y1 minus y2. That is not they confuse their x's with their y's. So just always rise first, always the horizontal change or the vertical change first, and then the horizontal. So it's like we're trying to get from this point, x1, y1, to this point. Tell me how to get there. Tell me how high or how low to go, and how far left and how far right to go. Okay, so a good non-example is that. So slope-intercept form of an equation, of a linear equation. So slope-intercept form, it gives it to you. It has to have the slope and it has to have the intercept. And remember what the slope was. The slope was m, and the intercept is denoted as 0b. That's the y-intercept, where that line crosses the y-axis. So here, our slope-intercept form has our slope and has our intercept. So this is our slope, and this is our y-intercept. Y equals mx plus b. And so some examples, I'll go over some examples. So y is equal to, 3x plus 5, where 3 is our slope, and our y-intercept is 0, 5. So when we go to graph this, we find our y-intercept, we graph it, and we use the slope our change of y over change of x to plot in a few other points. So let's see. So m is equal to the slope, which again, we can use y2 minus y1 over x2 minus x1. If they gave us 2 points and we need to find the slope, that's it. And then our y-intercept, b is our y-intercept, which on the graph it looks like 0b. And some non-examples is when 3x plus 2y is equal to 6. That's not in slope-intercept form, although that is a line. It's not in slope-intercept form. And you can create some other non-examples as well, but I'll just leave that to you. Okay, so that's slope-intercept form. Moving on to standard form of a linear equation. Standard form of a linear equation is like this guy, what I wrote here. So here, it's in the form of ax plus by is equal to c, where a, b, and c are real numbers. So here are some facts where a, b, c are real numbers. So again, the only variables are my x and y. And some examples. 5x plus 4y is equal to 20. 3x plus 7y is equal to, 51. This is just where x and y are on the same side of the equation. And some non-examples, if it's in another form, if it's a quadratic, things like that. Those are some non-examples. Okay, so that was slope-intercept form, standard form of an equation, and then the slope formula. So those, keep in mind that we're going to go over the slope formula a little bit later. So we can come back to that one. And you'll be seeing these ones as well. So moving on to the first lesson of this day, identify equivalent ratios. Okay, so we've been dealing with ratios. Let's go ahead and look at the worked example. A recipe for an organic bug spray has a 2:3 ratio of water to vinegar. So remember, that's water, that's vinegar, right? Mia mixes 6 cups of water and 9 cups of vinegar. Is the ratio in Mia's recipe equivalent to the organic bug spray recipe? So remember, we can represent it as a ratio where we have 2 to 3. So we have 2 boxes with water and 3 parts vinegar. And again, we can go just based off the model if we wanted. So here, if this was 6, each one of these, because we have 6 cups of water right here, each one of these boxes would have to be 3, because 3 plus 3 is 6. And so is this 9? It is, right? So that is an equivalent ratio, but that's not what they want us to do. But we can go off based off the picture as well. Here they used a table, so we find a multiplier to get us to our 6 cups of water. So that's 3. And if we multiply this guy by 3, we get 9. So those are equivalent ratios. And we circle is an equivalent ratio. Okay, so let's go to the try it. In City A, the coastline erosion rate of feet per year is 6 to 2. In City B, sorry about that. In City B, the coastline erosion rate is 12 to 3. Are the erosion rates equivalent? So here we have a table, 2 to 6 and 3 to 12. They kind of flipped it on us, but it's the same here. So let's make the table. This is time, distance. So 2 to 6. That's our original, right? Or 6 to 2, but they flipped it. So here, how do I get 2 times what number is 3? Well, that's just times 1.5. If we use our calculator, 3 divided by 2 is 1.5. It is. Okay. And then if we multiply 6 times 1.5, what are we going to get? 9. So that's an equivalent ratio. Is 3 to 12 the same as 3 to 9? No, it's not, right? So erosion rate of city A is not equivalent to the erosion rate of city B. Because these are equivalent right here, 2 to 6 and 3 to 9. So 3 to 12 could not be equivalent to those ones. Oh, that's super thin. There we go. That's not equivalent to the other two. Okay. So making equivalent fractions, you can also represent it with a model and do it that way if that makes more sense to you. Whatever works. So go ahead and pause this video, complete this practice section on identifying equivalent ratios. Okay, so you should have done that. Now moving on to solve ratio problems. So let me take a look. Yeah. So let's read this worked example. The ratio of buses that run on electric to diesel in a city is 3 to 7. The city has 36 buses running on electric. How many more buses run on diesel than electric? So here they drew it out. We have 3 parts electric to 7 parts diesel. And here we want to keep in mind that we're looking for a difference. How many more is just the difference. So different quantities here. So, and we know that 36 are already running on electric. So if 36 were electric, each block or each box has to be 12, right? And so here, the difference is 12 times 4. So, or 4 times 12 is 48. So there are 48 more buses running on diesel than electric. And then we can always check our work. So diesel is 7 times 12, that's 84. So this whole thing is 84. And 84 minus 36, it in fact is 48. So that checks out. Okay. Moving on to the try it. Raven City ratio of composted to recycled trash is 1 to 2. The city composts 5 tons of trash. How many more tons of trash does the city recycle than compost? Okay, so we have compost to recycle. So altogether, oh, wait, no, sorry. The city composts 5 tons. So the compost is equal to 5 tons. So how many more? Again, what's the difference between the top and the bottom? It's just this one. And each is worth 5. So the difference is just 5, right? So Raven City recycles 5 more tons of trash. And we check our work. So here the total would be 10. And so recycle, since it's bigger, recycle. The difference between recycling and composting. Well, they recycled 10, they composted 5, so 5 is the difference between the two. Okay? So here, drawing a model always helps with these types of problems. Go ahead and use that to complete these two. They look very similar. So go ahead and pause this video and do that now. Okay. So moving on to the last lesson. This is our algebra lesson. So the learning goal is I can calculate the rate of change between 2 points and use it as a slope for a line on a graph. So here this comes, or we're going to be talking about slopes and graphing and all that. So here we're focusing on slope-intercept form. The worked example is here and it's done for you, but I'm going to go ahead and move on since there's two examples that I can do with you. Let's go ahead and go to the try it, which is on page 22. So a community group is in the middle of a tree planting project. The group had already planted 10 trees, and the table below shows how many total trees should be planted at the end of each day. Find the progress rate. So we have to find a rate of the group, trees per day, and plot the points on a graph to help you answer the questions. So remember that our slope formula has two different points. We have this x2, y2, and x1, y1. So we have two different points. So that means we have to be given two different points to solve for the slope. So let's just pick two different points. I'm going to just pick these two since they're the smallest numbers. So x1 is 1, y1 is 14, x2 is 2, and y2 is 18. So we have, this is x1, y1, x2, y2. So from point 1 and point 2. And so now we're going to use the slope formula. So y2, where's my y2? That's right here. So that's 18. My y1 minus y1, so y1's right here. So 18 minus 14, so the two y's subtracted. And then x2 is 2 minus x1 is 1. So here 18 minus 14, that's just 4. And then 2 minus 1 is 1. So 4 divided by 1 is just 4. So the slope is 4 trees per day. So with each day we're increasing by 4. Step 3, plot the points and use the slope information to fill in the graph and answer the questions below. Okay, so we have 114. So about there. 218. 322. And I'm getting that from this table right here. 426. 530. Okay. So here each day we're increasing 4 trees. So it says here, so just to get a visual, with each day that goes by, we're increasing 4. So 1, 4, over 1, up 4, over 1, up 4. Or you can go the other way. The other way is up 4, over 1, up 4, over 1. So keeping that in mind, how many trees can the group expect to have planted by the 8th day? So here, we stopped at 5. How many more days is until 8? So we have 1, 2, 3. So that means we're going to have 3 days, but if we're going each day, we're increasing by 4 trees. How many times do we have 4? We have 4, 1, 2, 3 times, right? So we have to go from 30, we have to go 12 more times for the trees. So if we just keep going in this order, so I'll use the pink. So we have up 4, So 34 over 1. So this one's going to be 634. And we go up 4 over 1, so 38. This would be 38. And then up 4 over 1. So the 8th day would be 52. So this is 852. So before I was saying, if we're going to go, each time we move over 1, we're going up 4. So that's 1, 2, 3. We have to go up 4, 8, 12. So we have to go up 12 if we move over 3. Oh, sorry, that's not 52, that's 42. There we go. Okay, so here on the 8th day, the group can expect 42 trees. So if the group keeps up this rate, how many days would it take to have a total of 90 trees planted? So here, where do we start? We started after 1 day, we started at 14. So we want to get to 90. If we choose any number, so let's choose this guy, 530. And we want to know at how many days we will have 90. And so let's use our slope formula. And we know our slope is equal to 4. So here we have y2 minus y1, so 90 minus 30 on top, over x2 minus x1, so x minus 5. So here 90 minus 30 is 60 over x minus 5. So we know that 60 divided by something minus 5 is 4. So solving for that guy, I'm going to go ahead, I'll put it down here. So we have to multiply by the denominator, x minus 5. And then add 20. So we get 80 is equal to 4 times x. Divide by 4. X is equal to 20. So after 20 days, a total of 90 trees will be planted. So that was a lot of algebra. And we can just look at where we are at now. So we're at 42 now, and that's at 8 days. So what is the change from 90 to 42 on our graph? So here we want to get to 90. So 42, we have 90 minus 42. How many more days? So we have 90. That's 48 more days. So 48 more trees. And if you think about it, we have each day we're increasing by 4. So how many times does 4 go into 48? Well, we have 48 divided by 4. That's 12. 12 more days. So here, if we want to increase by 48 here, we have to go over 12 more days to get to our point. So that's another way of thinking about it. So 12 more days will put us at 8 plus 12 is 20. So this is 20, 90. So same thing. Using the change of y over the change of x here can really help us answer these questions below. If you're more of an algebraic thinker, you can set it up as an equation and solve for your unknown. Okay, so here, 20 days to have a total of 90 trees. Okay, so let's try another one. So here we have a local transit has a plan in place to replace all of their buses to hybrid models. The schedule below shows the plan checkpoints for how many buses are left to replace. Find the progress rate of the replacement plan, buses per month, and plot the points on the graph to help you answer the questions. Okay, so here I like to just do the first 2 points, 448 and 836. And so now we substitute these values in. So 36 minus 48, or vice versa, whatever. I'll do 36 minus 48. I'll keep it consistent. And then 8 minus 4. So 36 minus 48 is negative 12. 8 minus 4 is 4. So negative 12 divided by 4 is negative 3. So here we have negative 3 buses per month. So here, let's plot these points. So 448 at 8 we have 36. So maybe right there. 1224. 1612. And 20. So it looks like at 20 months, they replaced all the buses, right? So how long should it take to complete the plan? Okay, I just said that. So when does it reach 0? It reaches 0 at 20 months. So at 20 months, the plan is complete, right? Because we have no more buses to replace after that. So how many buses need to be replaced at the beginning of the plan? So here, at the beginning of the plan, the months are 0, right? Because nothing changed, or we haven't even begun yet. So at month 0, what is y? We don't have that yet, but we can figure that out. So here, if you look at every 4 months, we go down 12. So if we're going to work backwards, so here, if we look at this slope, we would go up 12 over 4, or to the left 4. So here, if we continue this slope, we're going to go up 12 over 4. And over 4, we're at 4 now. If we go over 4, we're going to be at 0. So all we have to do is go up 12 and find that number. So this was 48. 48 plus 12 is what? Is 60. So this is 0, 60 here. Or here you can do minus 4 plus 12 and get 60 at month 0, right? So initially there were 60 buses to be replaced. Okay, so here we really used our slope or rise over run to solve for with time 0. Okay, so go ahead and pause this video and complete this lesson 9 practice section. So there's 1, 2, 3, 4, but there's only 4 problems. Each problem takes up the whole page. And then last but not least, do the exit ticket. Once you're done with that, and once you're done with, oh, I don't have the software here. All the software for LEP 5, let's go to Google Classroom. And if on the stream, you can quickly access it right here in LEP 5. So you need to be done with most of it. So day 1 and day 2 should be done. So for this day, you need to do topic 3, lesson 3, just that one lesson, and then the success zone, and then you've reached the end of block 2. So once you've reached the end of block 2, come back and complete this LEP closer. Once you're done with that, turn in your credit, let me know so I can assign the